This is Precalculus, section 3.1 notes, part 2. So we were just about to start talking about zeros and their multiplicities. So if we have a multiplicity that is odd, okay, then what's going to happen is our graph crosses the x-axis at that point. So if we have a 0 at the point C and our multiplicity is odd, it's going to cross over the x-axis. It's going to look something like that. Okay, just two possibilities of what it could look like. Okay. Now if our multiplicity is even, then our graph does not cross the x-axis. So again, here's our point C. And so the graph may be approaching C, but it's not going to cross at C. Okay, so it's going to do something like that, or it's going to do something like that. It's going to, I like to call this bounces. I say it bounces at the value. I don't think that's a technical term, but that's a Mrs. Steele term. The graph bounces at that 0. So let's apply this to an example. It says sketch a basic graph of this polynomial. Oh, look at all those multiplicities. So the degree of my polynomial, if we count up our exponents here, would be 1 plus 4 plus 3, which is 8. So the degree of this polynomial is 8, which tells us that my basic shape is going to be a positive parabola. And really, what does that mean? It means both ends will be going up at the end. We have 3 different zeros. The first 0 comes from the first factor. It is x equals 2, and it has a multiplicity of 1, which means that the graph will cross here. Our second 0 is going to be at x equals negative 3. That has a multiplicity of 4, so that tells us that the graph will bounce here. And then finally, our third 0 is at x equals 5. That has a multiplicity of 3, so again, since it's odd, the graph will cross here. Okay, so I don't know any other information other than the 3 zeros and whether the graph bounces or crosses. But I have a basic idea based on that and the end behavior. So I can just put a few marks here on my coordinate plane and I can sketch a really basic idea of what this graph looks like. I know I've got a 0 at negative 3. I've got a 0 at negative 3, I've got a 0 at positive 2, and I've got a 0 at positive 5, okay? And I know based on my end behavior that the left side and the right side have to both go up, right? So that means that my graph is going up here, so it has to come down. I know that at negative 3, it bounces, okay? So it's going to come back up. But then I know at positive 2 it crosses, so it has to go through. And then at 5 it crosses again, so it has to go back through and then go up at the end to create that both ends up end behavior. Now, I have no idea how high the graph goes here or how low the graph goes here. I have no clue. That's why I didn't put any markings on my x-axis. So I'll just put a little note here. We need specific y values for a more accurate graph. Okay, so this is just a general shape, general idea of what this graph would look like. For our last example, we're going to do a little bit better as far as getting a better picture of what this graph actually looks like. So we want to graph this function p of x, So the first thing that we're going to do, nothing's been done for us on this one. So the first thing that we're going to do is factor. When I look at the function p of x, I can see that there's a GCF of x squared. So I'm going to take that out first. And then I'm going to have x squared plus 2x minus 8. And then that trinomial is an easy factor. Two numbers that multiply to make negative 8 and add to make positive 2 are going to be positive 4 and negative 2. So that's going to factor again. So I've got x squared times x plus 4 times x minus 2. So now I can see that I'm going to have 3 unique zeros. This one is x equals 0, but that has a multiplicity of 2. This one is going to be x equals negative 4. That has a multiplicity of 1. And this is going to be x equals 2, and again has a multiplicity of 1. I know based on end behavior rules that since my leading term here is x to the 4th, that the basic shape of my graph is going to be a positive parabola, meaning both ends will be up. My 3 zeros I already mentioned, but I'll mention again, are 0, negative 4, and positive 2. And based on their multiplicity, it is going to bounce at x equals 0, and it's going to cross at negative 4 and positive 2. So I'm going to go ahead and put my zeros in on my graph. So here's negative 4, here's 0, here's positive 2. Okay, now the last thing that I need to do here is make a little bit of a table, and I see that my table is kind of a little bit cut off here. I'm using my iPad, and I can't really adjust for that. So I'm going to choose, I'm just going to extend my table. Oops, I'm just going to extend my table over here. Here's my X and my Y, because I'm not going to have enough space there. Okay, so the X values that I want to choose surrounding my zeros, obviously if negative 4 is my leftmost zero, I'm going to choose negative 5. Then I need some zeros in between negative 4 and 0. And since that's kind of a big gap, I'm going to choose at least, you know, a couple here. And what the heck, let's do them all. Let's do negative 3, negative 2, and negative 1. This is just going to give us a really accurate picture of what's happening with our graph. Then we've got the 0, x equals 0. Between 0 and 2, we're going to have to do x equals 1, obviously. And then after the 0, x equals 2, we need one more. So how about if we do x equals 3? Okay. So now we're just going to plug these into our function. All right. And this, you can use your calculator for this. So we're going to get y equals, and you can either plug it into the factored form or you can plug it into the original form. It really doesn't matter. Maybe if you're doing it on your calculator, you might prefer the original form. That might actually be a little bit less typing, but whatever. So when we plug our x values in, we're going to have negative 5 to the 4th plus 2 times negative 5 cubed minus 8 times negative 5 squared. We do the math on that, and that gives us, 175. Okay, when x is negative 3, y is going to be equal to negative 3 to the 4th plus 2 times negative 3 cubed minus 8 times negative 3 squared, which gives us a value of negative 45. So there's that plunge below the x-axis because we know it's going to cross at our 0, negative 4. Okay, next we do x equals negative 2. So negative 2 to the 4th power plus 2 times negative 2 cubed minus 8 times negative 2 squared is going to give us a y value of negative 32. So I see now it's coming back up. When we do negative 1, we would expect it to keep increasing here. So let's see what happens. So y is negative 1 to the 4th plus 2 times negative 1 cubed minus 8 times negative 1 squared. We plug that in to our calculator and we get negative 9 for our y value. Yep, so still increasing. All right, now we've got a 0 and we know that it bounces there at x equals 0. So that means it's going to have to stay below the x-axis. So I would expect the y value that I get when I plug in x equals 1 is still going to be negative. Let's find out. So y equals 1 1 to the 4th, my apologies, plus 2 times 1 cubed minus 8 times 1 squared. And sure enough, when we plug that in, we get negative 5. And now I know that my graph's going to have to come back up because it crosses at x equals 2. So now I would expect my y value when x is 3 to be positive, to be above the x-axis. So we plug 3 in and we get 3 to the 4th power plus 2 times 3 cubed minus 8 times 3 squared. And when we plug that in, we get 63. Okay, so we are now ready to plot our points and make a graph. Note that our y values go from very large to fairly small. So I don't think we want to count on our y-axis by 1. If we want to be able to plot, well, I don't think we can plot 175, but if we maybe want to be able to plot like the 63 and the negative 45, then how about if we count by tens on our y-axis? Okay, so I'm going to call this 10, 20, 30, 40, 50, and then this down here, this will be negative 50, negative 40, negative 30, so on and so forth. I don't want to disrupt my writing there. Okay, so when I plot these points, negative 5, 175, that is off the charts, somewhere way up here. Okay, then when x is negative 3, I'm at negative 45, so right there. When x is at negative 2, I'm at negative 32, so right there. When x is at negative 1, I'm at negative 9, right there. Then I bounce. Then when x is 1, I'm at negative 5, and then I cross. And when x is at 3, I'm way up at 63, which is about right there. So my graph is going to look something like this. It's going to come down, it's going to come back up, it's going to bounce, go down, and come back up. Okay, so that's it's a more than decent graph. We've got a lot of real values on there, so that's a pretty accurate graph of what this function looks like.